Okay, so this is something you've done practically. You've worked out the gradient of x equals 0.7. So we're just going to try and find another way of doing that to help us come up with a more useful rule for working out gradients or differentiate functions. So we want to find the gradient at 0.7. So at this point here. So what we did, what you did, you just constructed the gradient. And you put 2 points on it and worked out the gradient xy, x2, y2 minus y1 divided by x2 minus x1. So let's just write that down. So the gradient, the definition of the gradient is y2 take away y1 divided by x2 take away x1. And that's what you would have done here. You would have found a point here. And maybe found another convenient point here. And worked out the change in y in those values. And then worked out the change in x using those values there. So when we use a tangent to work out the gradient, we have to estimate where it crosses the line. You know, we get a little bit of error doing that. We have found that when we compared the results from the rest of the class that you had slightly different results depending on where you thought it crossed the line. But what I do know with this function y equals x squared is I know the relationship with any value of x on this line. So that's going to help me. So what I'm going to do, I'm going to put an estimate for the gradient, and I'm going to put it here. I'm going to use that point because I know the gradient at that point. I know the coordinates at that point. So if I make my estimate here, and draw that line there, you can see it's not quite right, but it's an estimate. That's what we expect. It's not too far out, but it is out. But what I do know, I know the coordinates of this point, I know the coordinates of that point. So I can work it out and get a reasonable estimate. Then we can see how we can improve on that. So at this point is going to be so this is 0.7. So in this case, x is going to be 0.7. That's going to be x1. And then y, well, what I have to do, I have to square it. So I'll get a calculator out there. Do that. The 0.49. Didn't even calculator do that, did I? And that's going to be y1. So again, if I apply this same approach, I know this is going to be 0.1. Where have I got it? Point. That's going to be 1.1, 1.2, 1.3, 1.3. So at this point here, the gradient is going to be 1.3, and for y is going to be 1.3 squared, which is going to be 1.69. And I'm going to call this x2, y2. So I've got some numbers on there. So for gradient at, so if I put it, well, we did it 1.3, didn't we? That's how far away we put the line. So the gradient was y2 was 1.69. Take away y1, which is 0.49, and divide it by x2, which was 1.3. Take away 0.7. Again, we can just work that out on our calculator. That's going to be 1.69. Take away 0.49 divided by 1.3, take away 0.7. And that gives me a gradient of 2. So we know that's a little bit too steep. You've already worked it out, so you've got a rough idea of what the answer is. So if you think about how we can improve that gradient, how we can get that green line closer to the red line, the easiest way is to bring that green dot further down. So let's do that. Let me take the green dot all the way down to here. Oh, well, it's 1. So now I can see that the coordinates of this point here, well, x is going to be 1 and y is going to be 1 as well. That's quite nice, isn't it? So I can call this x2, y2. So we'll see what that does to the gradient. So when it is 1.0, the gradient was, well, actually y2 was 1, take away 0.49, and x2 was 1, take away 0.7. So we can work that out. So we've got 1, take away 0.49, divided by 1, take away 0.7. That came out 1.7, didn't it? 1.7. That was getting closer to actually what your gradient was, wasn't it? So let's take that one step further. Okay, I'm going to take the green line all the way down to here, down to, that's going to be 0.8. So at this point here, well, x is going to be 0.8, and then y is going to be squared 0.64. Now I can rename this as x2, y2. So 0.8, the gradient is going to equal y2, which is 0.64, 0.64, take away 0.49, because that point hasn't changed where we want the gradient to be, divided by 0.8, take away 0.7. Let's put that in our calculator and see what we get. 0.64, take away 0.49, 0.8, take away 0.7. Then we've got 1.5. Okay, that's getting closer. You can see what's happening when we move this green dot closer and closer and closer to the point where we want the gradient. You can see what's happening. The gradient is getting closer and closer to what the actual answer is. So let's be really, really pedantic and put our green dot really as close to it as I can get. And I'm going to say that is going to be, see what we get, 0.7001. That's really, really dead close to where we want it. So then if I work out the value of x squared, it's going to be 0.00. It's going to be again. So my calculator failed. It's going to be 0.7001 squared. It's going to be 0.49014. And we're going to call this x2 and x1, x2 and y2. Now this should be 0.7001. This should be very close to what the actual gradient is. So y2 is going to be 0.49014. Take away y1, and y1 is always going to be 0.49. So this is the point we want. And then we want to do x2, which is 0.7001, take away x1, which was 0.7. And if we put this in our calculator, let's get a good answer for that. So we have got 0.49014, take away 0.49, divided by 0.7001, take away 0.7. .4, and the actual gradient was 0.7 was 1.4. So if we put that, so if we say we've got a good idea for the gradient, just applying the rule for the gradient, but knowing that the closer we get that dot to the point where we want the gradient, the closer that answer is going to be. So our first estimate was 2, 1.7, 1.5, 1.4, and the actual one was 1.4. So we could use that process for doing it. But what we're going to do in the next video is look at how we get rid of the numbers and just come up with a formula. Because if I had a graph, maybe I have this one here, it was y equaled 3x squared, I could still apply the same to it. Much easier than plotting the graph out and doing it by hand. But what we want to do is to come up with a method that gives us the right answer without having to do all these calculations. So that will be in the second video that we've got in this maths folder.